Hello and welcome to the video on machine learning pipeline. In this video, I'll teach you the basic concepts and also show the practical implementation of the machine learning pipeline. So, in our various data science or ML project, this is the typical workflow. So, firstly, we try to collect or load or get the data, CSV data basically that we are working on. Then we perform the data pre-processing, data cleaning, feature encoding, feature transformation, etc. etc. Once the pre-processing and cleaning steps are done, then we finally move to the modeling part, and then if we want to deploy it on a cloud or a web service, then we can deploy our entire project. So this is a typical workflow of a machine learning project. Now usually what we do, we try to perform all the steps one by one. So firstly we'll just get the data by read CSV, then we will clean the data or fill the missing values, and then finally we'll train the model and uh, evaluate the model and finally deploy it. But we can perform all the steps in a single and a more efficient piece of code, that is the machine learning pipeline. So as you can see, what is a machine learning pipeline? A machine learning pipeline is a process of automating the workflow of a complete machine learning task. It can be done by enabling a sequence of data to be transformed and correlated together in a model that can be analyzed to get the output. A typical pipeline includes raw data input, features, output, model parameters, ML models, and predictions. Moreover, an ML pipeline contains multiple sequential steps that perform everything ranging from data extraction and pre-processing to model training and the deployment in machine learning in a modular approach. It means that in the pipeline, each step is designed as an independent module, and all these modules are tied together to get the final result. So, to understand the importance of a machine learning pipeline, let us first understand the typical workflow of an ML task. So, machine learning workflow, first we have the data ingestion, then we have cleaning, pre-processing, modeling, and finally deployment. So, a typical ML workflow contains ingestion, data cleaning, data pre-processing, modeling, and deployment. So, what happens in a machine learning pipeline? The cleaned data, so the output of one step is given as the input to the next step, as the name pipeline suggests. So the cleaned data is given as the input for feature encoding or whatever stuff that we want to perform in the pre-processing step. Then once we have cleaned plus pre-processed data, then that data will be given as the input to the model on which it will be trained, and finally then that will be deployed and evaluated. So this is the typical machine learning workflow, and we can improve that with the help of a machine learning pipeline. So in ML workflow, all these steps are run together with the same script. It means that the same script will use to extract the data, clean the data, model, and deploy. However, it may generate issues while trying to scale an ML model. So some of the issues can be, if we need to deploy multiple versions of the same model, then we need to run the complete workflow cycle multiple times, even when the very first step, let's say data ingestion or preparation, are exactly similar in each model. So these are the same steps. We only want to make tweaks in the machine learning model. The preparation of the data will remain the same. Now if we want to expand our model, we need to copy and paste the code from the beginning of the process, which is an inefficient and a bad practice in software development. If we want to change the configuration of any part of the workflow, we need to do it manually, which is more time consuming process. So for solving all the problems, we use a machine learning pipeline. With the ML pipeline, each part of the workflow acts as an independent module, and so whenever we need to change any part, we can choose that specific module and work as per our requirements. So I hope you are very clear with the basic understanding of ML pipeline and why do we use it and how it is more efficient than the standard workflow. Now let's move to the Jupyter notebook and I'll show you the practical implementation. So let us start with the practical implementation of machine learning pipeline. First of all, to demonstrate the practical, let me import few important libraries that we will need. So from sklearn, I need datasets. I'll use the iris datasets that we have in sklearn, and from sklearn dot model selection import train test split. Next thing is, one of the step in the entire pipeline will be of scaling, so I need the standard scaler. So from sklearn dot preprocessing import standard scaler. Next thing, I'll also perform some dimensionality reduction just as an additional step in the pipeline, so that the flow of the pipeline becomes very clear to you. So I'll perform something called the principal component analysis for dimensionality reduction. So I need to import that. So from sklearn dot decomposition import PCA, and finally a machine learning model that we are going to use. So let's use a decision tree. So that will be the model on which the entire pipeline, the ML pipeline will be trained. So sklearn dot tree import decision tree classifier. So we have imported all the required libraries. Now let's load the dataset. So iris is equals to data sets dot load underscore iris, and inside x we have iris dot data, and y will be the target. So iris dot target. So let's see what do we have inside x and the target y. So the data set is loaded. Now let's split the data. So x train, x test, y train, and y test will be train, test, split. We'll use the x, y, and test size will be, let's say, 20%, so 0.2. This is it. Now let's import the pipeline. So from sklearn dot pipeline import pipeline. Now let's create the pipeline flow. So I'll make one pipe, and this will be a pipeline object. So pipeline, the first thing that we are going to use is to perform the dimensionality reduction. So I'll do something like this, and inside this I will give here the PCA, that is principal component analysis, and I want it to be reduced to n components equal to 2. So n components that will be equal to 2, and then after that the next thing I want to do is perform the standard scaler. So I'll write something like this std, and this will be my standard scaler. And then finally in the third step I want the decision tree classifier, the model that we are going to use. So here I'll write dt, and this will be decision tree classifier. And finally, to get some details, I want to write verbose is equal to true. So this will show us some details. Now let's fit the data in the pipe. So again we'll use the same fit method. So pipe dot fit. This thing I will use x train and y train. So the data is fitting in the pipe. Now let's check the scoring of the data. So from sklearn dot metrics import accuracy score. So accuracy score will be y test, and here pipe dot predict and x test. So actually we are getting a very good accuracy, almost about 100%, which can be a case of little bit overfitting, but these are all the steps of the pipeline, and then this is the accuracy. I hope you are very clear with the practical implementation of machine learning pipeline in sklearn. Now let's move to the next.